Hello, I am Shahbaz Abid. This is General Physics 1 Lecture 6. From this lecture onwards, I am going to talk about vectors. Any physical quantity which has both the magnitude as well as the direction is known as the vector quantity. The examples which we saw earlier were displacement, velocity, and acceleration. Now, in the case of addition or subtraction of or multiplication of two vectors, we have to use vector operations. That is going to be discussed in part 2 of this lecture series. To set up the position of this vector, we have to organize a coordinate system. There are two types of coordinate systems. One is known as Cartesian coordinate system and another is polar coordinate system. In the case of the Cartesian coordinate system, the points are located by their distance along perpendicular axis. If you consider the left side, this is a two-dimensional Cartesian coordinate system. The point which has 0x and 0y is known as the origin. So the first value is x and the second value is y. Now if you want to locate an object on this coordinate system, let us consider this example here. You have to travel 2 units in the x direction and 3 units in the y direction to reach to this object here based on this origin. This coordinate system is divided into 4 quadrants. The first quadrant is going to have positive x and positive y as shown here. The second quadrant is going to have negative x and positive y. The third quadrant, both of them are going to be negative, and the fourth quadrant is going to be positive x and negative y. In the case of the three-dimensional Cartesian coordinate system, again we have the origin as 0, 0, 0, and to locate the point in the three-dimensional space, we have to get 3 coordinate values, which is going to be x coordinate and y coordinate and z coordinate to locate this point in the three-dimensional space. In polar coordinate system, the position of an object can be obtained as a distance from the origin to that object and the angle created from the reference axis. Now in the case of the two-dimensional polar coordinate system, the angle is taken usually from the positive x-axis, and if the angle is clockwise, that is going to be a negative angle, and if the angle is counterclockwise, it's going to be considered as positive angle. In the case of the three-dimensional polar coordinate system, you need to have 2 angles and the distance from the origin to that object to actually know the position of this object in the three-dimensional space. The phi angle is created from the positive x-axis between the xy plane, and the angle theta is created from the z-axis till that vector which is connecting the origin to that point. In order to represent a vector from one coordinate system to another coordinate system, let us consider vector A, which is between positive x and positive y axis. It is creating an angle from the x-axis as theta, and it is creating angle phi from the y-axis. Since it is between the x and the y-axis, it's going to be considered as a two-dimension vector. Now in order to convert from polar coordinate system to Cartesian coordinate system, let us switch a red light, and the shadow of this vector, in which the light cannot pass through this vector, is going to create a x component of this vector. If we switch off and we switch on the blue light, it's going to create a shadow on the y axis, and it's going to be a y component of the vector A. If we consider these two triangles, the hypotenuse of these two triangles is basically the vector A magnitude, and the other two sides are going to be the x component and the y component. Now if the angle is created from the positive x-axis, the x component of vector A is going to be A cosine theta. So it means what? From whatever axis the angle is created, that is going to have a cosine, and whatever the other side is going to have sine. So AY is going to be A sine theta. But if the angle is created from the y axis, so y component is going to have cosine phi and the x component is going to have sine phi. So to convert from polar to Cartesian, you have to see from which axis the angle is created. So if it is created from the x-axis, the x component is going to have cosine theta, and if angle is created from the y-axis, the y-axis component is going to have cosine phi in this case. If we want to convert from Cartesian to polar, we can again consider these two triangles, and by using Pythagoras theorem, we can get the magnitude A as a sub x square plus a sub y square whole root. We will get the magnitude A again. Since it's a right angle triangle, we can calculate angle theta and angle phi. The angle theta is going to be equal to tan inverse of opposite over the adjacent. In other words, perpendicular over the base. So it's going to give us angle theta. Now in the case of angle phi, the base becomes AY or adjacent becomes AY, and the opposite or perpendicular becomes A sub x. So it's going to be just A sub x over A sub y. Tan inverse of it is going to give us angle phi. Let's see example 1. Express 5, 75 degrees as Cartesian coordinates. 5 is actually the magnitude of this vector, and the 75 degree is the angle taken from the positive x axis. So the x component is going to be 5 cosine 75 degree, because the angle is created from the x axis, so it's going to give us 1.29 units, whereas y is going to be 5 sine 75 degrees, it's going to give us 4.83 units. Let's see example 2. Express 4, 1 radian as Cartesian coordinates. Now 4 is representing magnitude of this vector, and 1 radian is representing the angle in radians taken from the positive x-axis. You have two options to solve this problem, either to convert your calculator to radian, or you can convert the radian to degrees by basically multiplying with 180 over pi. You will get the angle in degrees as 57.3 degrees. Now again, the angle is created from the x-axis, so the component x component is going to be cosine theta, and the y component is going to be sine theta. So 4 cosine 57.3 degrees will give you 2.161, and the y component is going to be 4 sine 57.3 degrees is equal to 3.366. Let's see example 3. Express 4, 120 degrees as Cartesian coordinates. Again, 4 is the magnitude of this vector, and the angle is given from the positive x-axis as 120 degrees counterclockwise. So again, the angle is created from the x-axis, so the x component is going to be cosine of that angle 120 degree. So 4 cosine 120 degree is going to give us minus 2, whereas y component is going to be 4 sine 120 degrees is equal to 3.464. Let's see example 4. Example 4 is going to be similar to example 3, but now since the angle from the x-axis is 120 degree, let us take the angle now from the y-axis. So it's going to be 120 minus 90 degrees is going to give me 30 degrees counterclockwise angle taken from the positive y-axis, and we can check our solution of example 3 with this example 4. So now, since the angle is now taken from the positive y-axis, so it's going to have y component as cosine of this 30 degree, and the x component is going to be sine of this 30 degree. Since it is counterclockwise and it is on the left side and the angle is less than 90 degree, we know that we are in the second quadrant, so the x component is going to be negative. So 4 sine 30 is equal to 2, but we have to keep the negative sign because it is on the second quadrant. Whereas y is going to be 4 cosine 30 is going to be 3.464, and it is positive because we are in the second quadrant, and in the second quadrant the y is positive. Let's see example 5. Express 3, 4 as polar coordinates. So now we are given a Cartesian coordinate. Position of this vector is going to be 3 in the x direction and 4 in the y direction. We now have to convert it to polar coordinate, which means we have to calculate the magnitude of this vector, and we also have to calculate the angle created from the positive x axis. So since we have traveled 3 units in the x and 4 units in the y, this has created a triangle, and we can again use Pythagoras theorem to get the magnitude a, for example, to be equal to 5 units. And if we want to calculate the angle theta, it's going to be perpendicular over the base, and tan inverse of that is going to give us the angle 53.13 degrees. Let's see example 6. Express -3, 3 as polar coordinate. So now we are in the second quadrant. We have moved -3 in the x direction and +3 in the y direction to reach to this vector. Again, the triangle is created here. We can use the Pythagoras theorem to get the magnitude of this vector, and the magnitude of the vector is always positive. And now we can calculate the angle alpha. The angle alpha is going to be tan inverse of perpendicular over the base. Is going to give us the angle equal to -45 degree. Now negative indicates that the angle is a clockwise angle taken from any axis, and in this case it is taken from the negative x axis. If I want to calculate the angle from the positive x axis, we have to subtract from 180 45 degrees to give us the angle theta to be 135 degrees from the positive x axis counterclockwise. Let's see example 7. Express -4, -4 as polar coordinates. Now we have moved -4 in the x direction, in the negative x direction, and we have moved -4 in the negative y direction, and now we are in the third quadrant. Since it has created a triangle, again we can use Pythagoras theorem to get the magnitude of this vector to be equal to 5.66 units, and the angle alpha can be calculated as perpendicular over the base is going to give us 45 degrees. Now this 45 degrees is positive number, which means the angle is counterclockwise. If I want to calculate the angle from the positive x axis, we can add 180 degrees to 45. We will get the total angle from the x axis counterclockwise angle to be equal to 225 degrees. Let's see example 8. Express 4, -4 as polar coordinates. Now in this example we have moved 4 units in the x direction and -4 in the negative y direction is going to give us a right angle triangle again, and the hypotenuse of this triangle, which is basically the magnitude of this vector, can be calculated by Pythagoras theorem, and we will get it equal to 5.66. Angle alpha is going to be tan inverse of perpendicular over the base, is going to be -45 degrees, and it's a clockwise angle, that's why it is a negative angle, and it is again taken from the positive x axis. If we want to calculate counterclockwise angle from the positive x axis, we have to basically subtract 45 from 360 degrees, because the total is 360 degrees. We are going to get the theta from the positive x axis counterclockwise until this vector to be 315 degrees. Thank you, and I will see you in the next lecture.